Hello viewers, welcome to my channel. I'm Hasham Ali Khan. Last video, four problems I have completed on finding out the IBFS, initial basic feasible solution. Two problems by northwest corner rule and two problems by least cost method. Now in this video, two more problems I'm going to explain you about the IBFS by Vogel's approximation method, VAM. Comparatively, VAM is much superior compared to northwest corner and least cost method. Because the solution which we get, the IBFS which we get through VAM will be very near to the optimum solution. Many a times IBFS itself will become optimum. Sometimes only one or two tables may require to reach the optimum solution. So whatever time spent in finding out the IBFS, that will be cleared off by having shorter time in finding out the optimum solution. In examination, if nothing is asked, if it is asking you only to find out the IBFS, always go through VAM, not by least cost method or northwest corner rule, right? Now, in this IBFS by VAM, we have to take the penalties, row penalties and column penalty. Penalty means the difference between the smallest cost and the next smallest cost. The difference between the smallest cost in each row from the next smallest cost. That difference is called the penalty. So we find the penalty for each row and each column. So here you see the problem number 5. Determine the initial basic feasible solution using Vogel's method, VAM method. The sources are 1, 2, 3. So we give the name S1, S2, S3. Similarly, destinations are 1, 2, 3, 4. We call it as D1, D2, D3, D4. And the total supply 11, 13, 19 and total demand is 6, 10, 12, 15, 43. 43 is the total. That means the total of demand and total of supply both are equal. It's a balanced problem. And the costs are given. To supply 1 unit from S1 to D1, 21 rupees. To supply 1 unit from S1 to D2, 16 rupees. Like the transportation table is given. So before starting the problem, I expect my viewers to have a printout of the problems which I have given in the link under my description. Always keep ready the problems and also a notebook, calculator, pen ready while watching the video. So you maintain the notes, you work out the problems. Then only you will get perfect on the problems of transportation. Now, first of all, whatever transportation table is given in the problem, same table I have drawn. Source S1, S2, S3 and destination D1, D2, D3, D4. Then total supply. So up to this, the table is same, whatever is given in the problem. I have copied the values. The cost is given in the middle, but I have taken at the upper right corner. Because in the middle, I'll make the allocation of units. So only on the right corner, I'm taking the values, right? The total supply 11, 13, 19, total is 43. The total of supply and total of demand is 43. Balanced problem. Now, the new point in this way is penalties. We have to find out the penalties. Penalty is the difference. Write it down, note it down. Penalty is the difference between the smallest cost and the next smallest cost in every row and every column. First row, 21, 16, 15, 13. So in this cost, which is the minimum cost? 13. After 13, what is the next minimum? 15. So 15 minus 13, 2. So here I am writing row penalty 2. Similarly here, the minimum cost is 14 and the next minimum is 17. So 17 minus 14 is 3. The minimum cost here is 18. 18 is the minimum. The next minimum is 27. So 27 minus 18, you will get 9. So here I am taking 9 penalty. The row penalty is completed. Now I am going to take the column penalty. The first column 21, 17, 32. The minimum is 17 and the next minimum is 21. So 21 minus 17 you will get 4. So I am writing 4 penalty. Next column 16, 18, 27, these 3 values. The minimum is 16, next minimum 18. So 18 minus 16 is 2. Here minimum is 14, next minimum is 15. 15 minus 14, 1. Here minimum is 13, next minimum is 23. So 23 minus 13, it is equal to 10. That's all. First penalty we have calculated for row as well as column. In these penalties, select the highest penalty. 2, 3, 9, 10, 1, 2, 4. The highest penalty is 10. Rounded off this 10. In which column we are getting this 10? In D4 column. In this D4 column, what is the minimum cost? The minimum cost is 13. So allocate in this cell of 13. So row total 11, column total 15, whichever is less. So here 11 is less. So I am allocating 11 here. 11 minus 11, 0. 15 minus 11, 4. So whichever row or column has become 0, that should be blocked. Here this row has become 0. So block the row. Like this, I am blocking the complete row. That's all. First penalty completed. Now I am coming to the second penalty, penalty number 2. Now this row already blocked, already over, so no need to calculate the penalty. Now second row, 17, 18, 14, 23. Minimum is 14, next minimum is 17. 17 minus 14 is 3. 17 minus 14 is 3. Next one, 32, 27, 18, 41. Minimum is 18. Next minimum is 27. 27 minus 18, 9. Right? Column wise, 17 to 32. Only 2 values are there. 17, 32. So minus 32 minus 17. You are getting 15. Similarly, 18, 27. So 27 minus 18. You will get 9. Here 18, 14, 18, so 4. Here it is 23, 41. So 41 minus 23, you will get 18. 18, that's all. Now, what is the highest penalty? The rows 3, 9. Here 15, 9, 4, 18. The highest penalty in second case is 18. So round off the 18. In which column we are getting this 18? Again D4 column. So what is the minimum cost in this D4? 23 or 41? 23 is minimum. So I am going to allocate in this 23 cell. The column total is 4 and the row total is 13. Whichever is less. 4 is less. So I am allocating 4 here. 4 minus 4, 0. 13 minus 4, 9. The column is 0. So block the column. That's all. 2 penalties completed. Now I am coming to the third penalty. First row already exhausted. Put a dash. Second row 14, 18, 17. The minimum is 14. Next 17. 17 minus 14 is 3. Here 32, 27, 18. Minimum is 18. Next minimum 27. So 27 minus 18, 9. Right? Column wise, 32 minus 17, again we'll get 15. Then 27 minus 18, 9. Here 18 minus 14, 4. Here exhausted, 0, so put a dash. This is the third penalty. Now find out what is the highest penalty. The highest penalty is 3, 9, 15, 9, 4. So 15 is the highest. Round off this 15. In which column we are getting? First column we are getting. What is the minimum cost in this column? 17. In this column, minimum cost is 17. So we allocate here. What is the row total here? 9. Column total 6. 9 or 6, whichever is lower. 6 is lower. I am allocating 6 here. 6 minus 6, 0. 9 minus 6 is 3. This has become 0. So block the column. Block the column. That's all. 3 penalties completed. Now fourth penalty. Fourth penalty. First row dash. Second row 14, 18. Only 2 unoccupied cells. So 18 minus 14, 4. Right? Next 27 minus 18, 9. Column wise, first column is over. Put a dash. Second column 27 minus 18, 9. Third column 18 minus 14, 4. That's all. Now find out the highest penalty. Here the highest penalty is 9. Here also highest penalty is 9. There's a tie. There's a tie in penalties. Both are 9. Then we see the allocations. If we arbitrarily select this 9, what is the minimum cost here? 18 is the minimum cost. Because if we select this 9, 18 is the minimum cost. Right? If we select this 9, again 18 is the minimum cost. There's a tie in cost. There's a tie in penalty, 9, 9. There is a tie in cost because if we select this 9, 18 rupees and this 9, again 18 rupees. Now third case is we compare the allocations. Wherever we can give more allocation, that should be selected. Suppose if we select this 9, we'll get this 18. This 18 means row total 3, column total 10, whichever is less. So only 3 allocations we can make. Arbitrarily I am writing. Here, if we select this 9, this row total 19, column total 12. Minimum is 12. So 12. Now see carefully. If we select this 9, we are getting allocation of only 3. If we are selecting this 9, we are getting allocations of 12. So wherever we can give more allocations, that we will select. We will not select this 9. Because if we select this 9, only 3 allocations we are getting. If we select this 9, then we are getting 12 allocations. This is better. Right? So 12 minus 12 will become 0. Here 19 minus 12, 7 will remain. So column is exhausted. This is exhausted. Over. Now, only one column, only one unoccupied cell is there in the second row. Second row, only one unoccupied cell is there, where row total is 3 and column total is 10. Whichever is less. So 3 is less. So here I am allocating 3. 3 minus 3, 0. 10 minus 3, 7. Now if you observe, only one unoccupied is left. And the row total is 7. Column total is also 7. So I'll make allocation 7 here. 7 minus 7, 0. 7 minus 7, 0. Now all the cells are either occupied or blocked. No unoccupied cell is there. And the total are 0, 0, 0, 0. Here also 0, 0, 0, 0. That means we have correctly made the allocations. This is called VAMP's method of finding out IBFS. So arbitrarily I have taken 5 penalties, but we got the solution only in 4 penalty itself. Right? Now we'll find out how many allocations are there. 1, 2, 3, 4, 5, 6. 6 allocations are there. So number of allocations are 6. Number of allocations are 6. M plus n minus 1 is equal to, M means number of rows, 1, 2, 3 rows, plus n means number of columns, 1, 2, 3, 4, minus 1. So 3 plus 4, 7, 7 minus 1, 6. Since number of allocations are equal to m plus n minus 1, so the problem is non-degenerate. It is called, problem is non-degenerate, feasible. We can proceed. We can go ahead. Right? This is the end of this IBFS. Now we'll find out the total cost. So first allocation is S1 to D4. So I'm taking S1 to D4. How many units? 11 units. Unit cost is 13. Second allocation is S2 to D1. S2 to D1. How much? 6 units? 17 rupees. S2 to D2. S2 to D2. 3 units? 18 rupees. Then S2 to D4. S2 to D4. 4 units? 23 rupees. Then S3 to D2. S3 to D2. 7 units? 27 rupees. And S3 to D3. S3 to D3. 12 units? 18 rupees. That's all. 1, 2, 3, 4, 5, 6. 6 allocations are there. Now simply we multiply 11 into 13. 11 into 13 is equal to 143. 143. 6 into 17 is equal to 102. 3 into 18, 54. 23 into 4, it comes to 92. 27 into 7, you will get 189. 12 into 18, you will get 216. Now we add up 143 plus 102 plus 54 plus 92 plus 189 plus 216. It comes to 796. That's all. This is the end of problem number 5. First time, it may appear some difficulty in understanding. But if you do 2-3 problems, it will be very much easy. And comparatively, VAM is much superior than northwest corner and least cost method. Now, 6th problem. See the problem number 6. Obtain the initial basic feasible solution to the following transportation problem. If nothing is given, we always prefer to go by VAM. So here warehouse A, B, C, D. Then stores are 1, 2, 3, 4. So 3 supply origins and 4 supply origins and 4 destinations. Availability 34, 15, 12, 19, total 20. And demand 21, 25, 17, 17. The total is 80. Balanced problem. The total supply and total demand both are equal and the unit costs are given. Exactly same way what we have done. I have drawn the table. Warehouse A, B, C, D. And the stores are 1, 2, 3, 4. And the costs are given in the problem 7, 5, 8, 6. I have taken it at the upper right corner. Right? The demand is 21, 25, 17, 8, 17. And availability 34, 15, 12, 19. Total is 80. This table is completely given in the problem. What I have done, I have drawn the penalties. This is called column penalty. 1, 2, 3, 4, 5, 6. Arbitrarily I have taken 6. We may get the answer either in 4 penalty or 5 penalty itself, sometimes 6 penalty. To be on the safer side, I have taken 6 penalties. So row penalty 1, 2, 3, 4, 5, 6. Totally 6 penalties I have taken. Penalty is the difference between the lowest cost and the next lowest cost. In the first row, the lowest cost is 3. And the next lowest cost is 5. So 5 minus 3, 2. Second row. In the second row, minimum cost is 5. Next minimum is also 5. So 5 minus 5, 0. Here, the minimum cost is 5. Third row, minimum cost is 5. Next minimum cost is 6. So 6 minus 5, 1. Here the minimum cost is 1. And the next minimum cost is 4. 4 minus 1, 3. Now come to columns. In the first column, minimum is 5. Next minimum is 6. So 1. Here minimum cost is 1. Next minimum is 3. So 3 minus 1, 2. Minimum is 5. Next minimum 6. So 6 minus 5, 1. Minimum is 4. Next minimum is 5. So 5 minus 4, 1. So we got the first penalty for row as well as column. Now select the highest penalty in that row and column, both. So if you go by column, 1, 2, 1, 1. In row, 2, 0, 1, 3. Highest penalty is 3. So round off these 3. In which row we are getting this 3? In the D row. In this D row, what is the minimum cost here? 1. The minimum cost is 1. So we are going to allocate in this one cell. The row total is 19, column total 25. So whichever is low, 19. So here 19 I have allocated, 19 minus 19, 0. 25 minus 19, 6. Over. The row has become 0. So exhausted. Block the row. This row I am blocking. That's all. Over. Now second penalty. Second penalty again, minimum is 3. Next minimum 5. 5 minus 3, 2. Minimum is 5. Next minimum is 5. 5 minus 5, 0. Minimum is 5. Next minimum 6. 6 minus 5, 1. This is already exhausted. Put a dash. Column wise, minimum is 5. Next minimum 7. So 7 minus 5, 2. Minimum is 3. Next minimum 5. 5 minus 3, 2. Minimum is 5. Next minimum 6. 6 minus 5, 1. Minimum 5. Next minimum 5, 0. That's all. Now what do you observe here? The highest penalty is 2. 2, 2, 1, 0, 2, 0, 1. The highest penalty is 2. But 2 is occurring 3 times. So when there is a tie in penalty, locate the cost. Wherever we are having lower cost, that we will select. If we select this 2, what is the lowest cost we are having? 5 rupees. If we select this 2, the lowest cost 3 rupees. If we select this 2, the lowest cost 3 rupees. So 3 rupees is common whether you select this 2 or this 2. So we are comparing the cost. If we select the first 2, the minimum cost is 5. If we select the second 2, the minimum cost is 3. So wherever lower cost, that is preferred. So this 2 I am selecting. This 3. How much allocations I can make? Row total 34, column total 6. So 6 allocations I can make. So 6 minus 6, 0. Here 34 minus 6, it is 28. Right? The column has become 0. So block the column. Block the column. That's it. 2 penalties completed. Now third penalty. First row, minimum is 5. Next minimum also 5. 5 minus 5, 0. Here minimum is 5. Next minimum 6. So 6 minus 5, 1. Here minimum is 5. Next minimum 6. 6 minus 5, 1. This is blocked. Now here, minimum is 5. Next minimum 7. So 7 minus 5, 2. This is blocked. Then minimum 5. Next minimum 6, 1. Minimum 5. Next minimum 5, 0. That's all. Now in the third penalty, what is the highest penalty? You see here. Here the penalty is 2. 2, 1. Here 0, 1, 1. The highest penalty is 2. So round off these 2. What is the minimum cost in this column? Minimum cost is 5. So allocate in this 5 cell. Row total is 15, column total is 21. So 15 is minimum. So here 15 minus 15, 0. 21 minus 15, 6. Right? Now this row has been exhausted. So block the row. Block the row. That's all. So how many penalties completed? 3 penalties completed. Now I am coming to the fourth penalty. Fourth penalty, minimum is 5, next minimum 5. 5 minus 5, 0 penalty. Here it is blocked, dash. Here minimum is 5, next minimum 6. So 1 is the difference. This is blocked. Now come to columns. 8 minus 7 is 1. Here it is blocked. Then here 5 to 6, 1. Here 5 minus 5, 0. Now in this fourth penalties, 1 is the maximum. Because row columns you can see 1 dash 1 0. In row 0 dash 1 dash. The highest penalty is 1. but 1 is occurring 3 times. We select the cost. Wherever lower cost is there, that will select. If we select this one, what is the lowest cost here? 7 is the lowest cost. If we select this one. If we select this one, what is the lowest cost? 5. So we are not going to select this one, because if we select this one, 7 cost we are getting. If we select this one, 5 is the cost, right? This 5. And if we select this one, again 5. So there is a tie in cost. Now we see the allocations. Wherever more allocations are there, that will select. If we select this one, this 5. So how many allocations we can give? This column 17, row 28, whichever is less. So 17 we can give. Arbitrarily I am writing. I am checking now. This 5 if we select, row total 12, column total 17. So 12. Now you can carefully see. If we select this one, 17 allocations we can give. If we select this one, only 12 allocations we can give. So wherever we can give more allocation, that should be preferred. So we are not going to select this one. We are going to select this one. So when we select this one, what is the minimum cost? 5. So row total 28, column total 17. So 17 we can allocate. So 17 minus 17, 0. 28 minus 17, you will get 11. Right? So this column is blocked. That's all. Now still 4 more unoccupied cells are there. 1 more penalty is required. 1 more penalty. So 5, 7. 5, 7. So 7 minus 5, 2. 2 is the penalty. This is exhausted. So 8, 5. So 8 minus 5 is 3. This is exhausted, dash. Here 7, 8. 1 is the penalty. Here exhausted. Here exhausted. Here 5, 5, 0. Now you can see 1 dash dash 0 and there 2 dash 3 dash. Highest penalty is 3. So round off this 3. In which row we are getting this 3? Row C. So what is the lowest cost in this row? 5. Select this cell. So 12, row total 12, column total 17. So here I am taking 12, 0. 17 minus 12, 5. This 0, that means this row is blocked. That's all. Now we don't require any other penalty, because if any row or column only one unoccupied cell is there, we take the balance. If any row or column only one unoccupied cell. Here in this column you can see. In this column only one unoccupied cell is there. What is the column total here? 6. So I am allotting 6 here. 6 minus 6, 0. Here 11 minus 6 remains 5. Now only one unoccupied cell is there in the whole table. One unoccupied cell. So what is the row total here? 5. Column total 5. So if I allocate 5 here, this 5 minus 5, 0. 5 minus 5, 0. That's all. Now you can see all the cells are either occupied or blocked. There is no unoccupied empty cell, right? Allocations completed. And all the demand and supply has become 0, 0, 0, 0, 0, 0, 0, 0, 0. All has become 0. So correctly we have made the allocations. Now number of allocations. Number of allocations is equal to. Now count how many allocations? 1, 2, 3, 4, 5, 6, 7. Number of allocations are 7. Then m plus n minus 1. M means number of rows. How many rows? 1, 2, 3, 4 rows. Plus number of columns. 1, 2, 3, 4. Minus 1. So 4 plus 4, 8 minus 1 is equal to 7. Number of allocations are 7 and m plus n minus 1. Number of rows are 4. Number of columns are 4. So 4 plus 4, 8 minus 1, 7. You should write the number of allocations are equal to m plus n minus 1. So the problem is feasible. The problem is non-degenerate. So we can proceed to calculate to find out the optimum solution that you have to write. Now what is the total cost? The first allocation is A to 1. A to 1, how many units? 6 units, 7 rupees. Then A to 2, how many units? 6 units, 3 rupees. Then A to 3, A to 3 is 17 units, 5 rupees. 17 units, 5 rupees. A to 4, A to 4 it is 5 units, 5 rupees. Then B to 1, B to 1 15 units, 5 rupees. Then C to 4, C to 4, how many units? 12 units, 5 rupees. Then last D to 2, D to 2 19 units, 1 rupee. That's all. So 1, 2, 3, 4, 5, 6, 7. 7 allocations we got it. Now simply multiply 6 into 7. 6 sevens are 42. 6 threes are 18. 17 into 5, it comes to 85. 5 fives are 25. 15 into 5, 75. Then we'll take 12 into 5, 60. 12 into 5. 12 into 5 is 60. Sorry. 12 into 5 is 60. 19 into 1 is 19. Now simplifying the total. 42 plus 18 plus 85 plus 25 plus 75 plus 60 plus 19. It comes to 324. That's all. This is the completion of problem number 6. The 2 problems I have completed in this video, that is problem number 5 and problem number 6 on IBFS by VAM method. So if you are satisfied, give a like to the video, share my channel, subscribe if you have not yet subscribed. Inshallah, we'll continue the next problem in the next video.